Alright, we're going to take a look at lesson 7.1. You had this last week, and we're just going to go over some basics of this one. We've already done the assignment, so here are the basics. A conjunction is when two statements are connected by the word and. The key to this is to remember is that a conjunction is true when both statements are true. Very important to understand that the word and represents both. You must have both statements true for a conjunction to be true. A disjunction, however, is combined by the word or, and for the other one, or for this one, a disjunction is true when at least one of the statements is true. So one of them can be false and you're still okay. Not as picky. Negation is the word involving the word not. So we say it's not sunny, it's not cloudy, or I'm happy. Not is what a old habit back in my day anyway was to say not when you wanted to make a joke. Now, with reference to these things, it's not hard to make a conjunction. Okay, and again, these next three statements here are repetitive of what we just said. Okay, both, at least one. Another one here is a negation is true when the statement without the word not is false. For example, I could say not cold. Is that true? Well, it's only true if cold is false. So if it's not cold outside, okay, you're outside and cold is not the correct word that you would use to describe the temperature, then to say, so that would make it false, then to say not cold is a true statement. So how do we form conjunctions? Well, we already know that and goes with a conjunction. So if we have two statements here, pi is a rational number, and 4 is a factor of 30. Conjunction would be to take either one and combine it with the word and. Pi is a rational number, and 4 is a factor of 30. A disjunction would be to basically make the same statement but replace the word and with the word or. So pi is a rational number, or 4 is a factor of 30. Form a negation of the second statement. 4 is a factor of 30 is what we are given. How do we negate that? We would say 4 is not a factor of 30. Okay, now we're getting into some basic beginning geometry here, so this may seem pretty fundamental, but it will help us through logical thinking in the next couple lessons. Draw a Venn diagram to show the relationship between isosceles triangles and right triangles. Now this is basically saying that in the world of triangles, how do we compare isosceles and right triangles? Well, first of all, we have to decide, is there such a thing as an isosceles triangle being a right triangle? Can they both occur at the same time? And that can happen. So this one right in the middle would share the characteristics of both. It would be a right triangle. It would also have two sides of equal length. This world would be right triangles. All of the right triangles that are possible, and all that says is that you have a right angle. Over here you have the world of isosceles triangles, and that would be anything that had two equal sides. And in the middle would be a combination of the characteristics, thus making it an isosceles right triangle. My symbol for triangle. Okay. Let's take a look at number lines first in terms of graphing. This is a review lesson for a lot of us, and the key to this is that we have to remember that if we have a less than or a greater than, then our graphs, our number line graphs, will have circles around the numbers. If we have less than or equal to or a greater than or equal to, we'll have filled in dots. Alright, here we have an OR. Now, an OR will be true if at least one of the two statements is true. So if we graph the first one, I'll do that in red, which would be 5. So let's go 0, 1, 2, 3, 4, 5. Less than or equal to 5 means solid dot. If it's less than or equal to, we go this way. Greater than 2, circle, arrow going this way. Now, all this says is any number that satisfies one or the other will work. So any number less than or equal to 5 will work, or any number greater than 2 will work. And that would represent basically all real numbers. Everything works. Even though this is a circle right here, it may not work for the first one, but it does work for the x less than or equal to 5. Now the word and is more picky. You have to have numbers that satisfy both. So if I go 0, and I say less than, I'm going this way. And if I have greater than or equal to -4, -1, -2, 4. Filled in dot, arrow going to the right, greater than. It is the numbers that satisfy both. So right to here. And again, 0 doesn't count for one of them, so it doesn't work for both. So we don't count that. But basically right here. Now if you want to graph that officially in a clean chart, you just have this. And we go to here, you'd have 0. And that's how you would graph a conjunction. So you don't care about these over here because it only satisfies one of them. It's only where they both overlap or have numbers in common that you accept. Graphing number lines, all right, or graphing XY charts. If you remember, y equals mx plus b, we have a y-intercept of -1. We have a slope of 1, and that's 1 over 1 for slope. So up 1 over 1, up 1 over 1. We have to decide here with graphing on a coordinate system, if it's greater than or less than, it's dotted. If it's greater than or equal to or less than or equal to, it's solid. We have this greater than, so it's going to be dotted. And they want to graph greater than. Now this is the word and. So we have to only take the parts that they overlap. So I'm going to basically start by doing this. Greater than, if this is the y-axis, we would say that the y's increase as you go up, get greater than as you go up, and get less than as you go down. So here we would shade greater than. So we want the y's that are greater than the line you drew. So that would shade up. Again, I'll clean this up later. Next one, we have no y-intercept on this one, so that's at 0, 0. Slope of 2 over 1, so up 2 over 1, up 2 over 1. This is dotted. And that one wants us to shade less than, so we would shade down. Now, because if it was or, we would just take it as is, but when it's and, we only take where they overlap. And that would be right here. That's where they both share and have in common.